Hello everyone. We are Team 2 of the University of Michigan 2G Lab Simulation Project from BE 605 Project Management class. Our members include Muhammad, Christine, Piyush, Wei, Li Yuan, Emily, Mansi, and Yashdeepson. The University of Waterloo students of BE 605 have commenced work on a university collaborative project between the University of Michigan and the University of Waterloo entitled the University of Michigan 2G Lab. This project is one that entails the creation of a simulation for students interested in humanitarian work or crisis response. Over the years, the world has seen an influx in natural disasters, which have rocked the nations affected to their core. The Indonesian tsunami, Hurricane Sandy, Hurricane Katrina, the Nepal earthquake, and many more. Oftentimes, the limiting factor to delivering timely and efficient aid is communication, or the lack thereof. How does an organization disperse aid across a disaster-riddled nation and get the right information and aid to the right people at the right time? The most important thing to do when faced in such chaotic conditions is to chart the flow of information and communication, from the lead aid provider at the command center, to the distribution warehouses, to the field agents, and then finally to the beneficiaries. One may ask, how can this be done successfully? Our project seeks to answer these questions by examining the communication limitations and challenges experienced in two real-life scenarios, the Nepal earthquake and the Indian Ocean tsunami as it relates to the food aid supply chain. It is noted additionally that in studying these two cases, that there exists what may be conceived as a vast disparity between the level of communication technology infrastructure available and in existence in each case, as one occurred in 2015 while the other 2004 respectively.
As it relates to the project scope, a key outcome for our project was to ensure that the learning objectives are met for the students of the University of Michigan undertaking the new Crisis Informatics course. These learning objectives include the ability of students to critically assess emergency and crisis situations and effectively identify, coordinate, and apply the relevant information technological responses that are necessary to the scope, severity, and phase of the crisis. The project deals with problem solving and design of tools that will work with slower mobile phone technology such as 2G. This technology is still being used in many developing countries. In accordance with the disaster management cycle, the teams will examine three phases of the disaster: rescue, relief, and rehabilitation and reconstruction. The rule associated with these phases is that the time frame for each is usually 7 days, 3 months, and 3 to 5 years respectively. However, they may vary depending on the severity of the event. The way in which the team intends to deliver the aforementioned objective is by creating two case study scenarios, as was mentioned before, that focuses on actual disasters that have occurred in world history.
As mentioned previously, our two case scenarios are based on the Nepal earthquake of 2015 and the Indonesian tsunami of 2004. The reason behind selecting the Nepal earthquake was that several parts of the country were totally disrupted, due to which there was limited connectivity in the affected areas. However, some areas were functioning well, and communication was comparatively easier and feasible. As for the Indonesian tsunami, it destroyed most parts of the country and left many people dead and homeless. Communication was one of the most important aspects that was disrupted, and people faced difficulties in communicating with their families, loved ones, as well as calling help from the military and the government.
Here we can see the project design. The simulation design drafted can be implicated in lab environment as well as an activity. The design approach to keep it flexible is based on the research conducted by the group. For the simulation to be effective and purposeful, great amount of data is required. The simulation can be used in multiple labs, as can be seen in the design flow diagram. Each role will be using different modes of communication to communicate with each other.
There are two utilities that can be used for our project. One would be ATC, which is the Augmented Traffic Control. It is a project that allows developers to control the connection that a device has to the internet. It can be used for testing over varying network conditions. The aspects that can be controlled by ATC include the bandwidth, latency, packet loss, packet corruption, and packet reordering. Because ATC runs on a gateway, any devices that are connected to a network routing through it can use it to shape its traffic. Traffic can be shaped as well as unshaped using a web interface, allowing any devices that have a web browser to use ATC without the need for a client application. Next, we have the Network Link Conditioner. It is another great software used to test applications under different network conditions. However, the software is developed by Apple and is only limited to iOS devices. It is a new utility in iOS that allows developers to simulate in less than desirable network conditions. This is an especially useful utility for those developing applications and sites that highly rely on network connectivity.
The figure below shows the workflow of the simulation. As can be seen, the Response Operation Manager communicates with the World Food Programme Headquarters, WFP, and have continuous communication with the Logistics Manager. The Logistics Manager is the key role in the chain as it communicates and gathers information from field agents, analyzes it, and submits report to the Response Operation Manager. Furthermore, the Logistics Manager communicates with Response Operations Manager to receive food aid, manages the storage and warehouse, analyzes the data, divides the aid, and then communicates with the field agent to provide them with the aid supply report. The field agent works closely with the community and the Logistics Manager, providing current status of the community and aid requirements.
The Food Aid Supply Simulator is a multiplayer simulation based on WFP's emergency response operations, with options to select 2 different scenarios. Students select one role from the given 3 roles. The simulation takes place over 3 different time frames, starting from the initial emergency response of 7 days, followed by decision-making for progress and stability, 3 months, and finally the future planning and forecasting stage, 3 to 5 years. Students will be provided with different modes of communication, varying in signal strengths and use. The goal is to understand how to balance competing priorities, make critical decisions, and manage food aid during different time frames. The roles and responsibilities include: once the user gets inside the user screen and select the given scenarios, he will be given a choice to select their role, or he will be assigned a role by the professor. Once the role has been assigned, a brief description of the role and main responsibilities will be highlighted to prepare them for the upcoming tasks.
The simulation is based on 2 different case scenarios. Food aid supply chain was focused in both scenarios, the Nepal earthquake and the Indonesian tsunami, and communication aspects under different timeframes were considered. These were selected to understand how different situations impact supply chain. The tasks for each role were designed to balance both the physical exercise as well as a desk exercise with some mathematical and decision-making strategies. Tasks for corporate roles such as country director and response operation manager were more focused on open-ended responses due to the nature of the role. From the research conducted and considering the responsibilities of these roles, prioritizing exercise, physical communication, report writing, and decision-making tasks were also developed. Logistics and warehouse manager plays a key role in the smooth functioning of supply chain. They have more responsibilities in terms of mathematical calculations and decision-making for distributing the food aid equally to satisfy the needs. Therefore, the tasks are calculation-based tasks along with physical communication with other roles along the supply chain. Similarly, based on responsibilities of the field agent, the task is designed to have better understanding of the role, which includes report writing, calculations, decision-making, and physical communication over various communication methods.
Next, we have solution scripts that will be provided, and they will be developed answering all the tasks in the simulation. The results were also obtained by researching and are based on the data gathered using case studies and published documentation, as well as articles of WFP.
In conclusion, the simulation package developed provides an understanding to the target audiences, students, non-governmental organizations, about how food aid supply chain works and what communication difficulties are faced along the chain. The simulation script details the tasks for main roles along the supply chain, for example, the logistics manager, and is designed to make participants experience all aspects encountered during an actual natural disaster and solicit from them the necessary real time response. From the research conducted, the tasks varied from physical communication between entities, report writing, mathematical exercises, and decision making activities. So, on behalf of Team 2, we would like to say thank you for your time and we hope you enjoyed our presentation.